Hi, myself Puja, Assistant Professor of GKCM of GIS Group, Department of Electronics and Communication Engineering. Here you will find the details of my contact information, and I have developed a Facebook page where regular updates regarding this course are available time to time. Hello everyone. Here in this session, I will be going to explain convolution code states and codes tree. So this is what I will be explaining by one example. So before we go for this explanation, let us have one convolution encoder. As I have explained in previous session, I have convolution encoder which is having constraint length 3 because there are 3 shift register was there, and first is have current message input bits, and that is having M, and next to that is explaining states of convolution code which is M1 and M2. So M representing the current input message and M1 and M2 representing the states of convolution code. Okay, so here for this one can say this M, that is what current message bit, and this 2 bit that is explaining state of convolution code. Now I will explain what will be the states of convolution code. Now see here, these three bits, that is what defining our output. If I say I have 2 output here, let us say this is output x1 and this is output x2, and resulting output that is getting switched between x1 and x2. So you will be finding like x1, that is what algebraic sum of bits which is connected here. If I say I am connecting all the bits here, so x1 is what? Modulo 2 sum of M, M1 and M2. And if I connect M and M1 here, then x2 is what? Then x2 is modulo 2 sum of M and M2. So here my output x1, that is M modulo 2 sum M1 modulo 2 sum M2, and output x2, that is M modulo 2 sum of M2. And what are the states which is there within convolution code? So basically one can say these preceding bits M1 and M2, that is depending the states. So M1 and M2 that will justify states, or we can say M1 and M2 that is defining the states of convolution code. So let us have 4 different states. As 2 bits are there to represent states. So here if M1 and M2 is 0, 0, then there is state A. If M1 and M2 is 0, 1, then state is B. If M1 and M2 is 1, 0, then state will be C. If M1 and M2 is 1, 1, then we can say the state is D. So this is how we are defining state. So this M, that is what defining current input, and these are the previous input bits which is there in M1 and M2 will justify the state of convolution code. So we will be observing. Okay, so we will be observing how states are getting changed with respect to change in current message bits and how output is getting changed as we insert bits. Okay, so we will be observing how states are getting changed with respect to change in current message bits and how output is getting changed as we insert bits. So initially all three bits are 0, 0, 0. So when you enter first bit, it will come here, and this bit in M, that is shift in M1, and the bit which is in M1, that will shift to M2. Okay, so the first bit it will come here, and this bit in M, that is shift in M1, and that bit which is in M1, that will shift to M2. Okay, so all those things I will explain by one example to have understanding of how to help code tree. So let us see by this one example. Okay, so what is code tree? So it is explaining each branch of tree represent an input symbol with the corresponding pair of output binary symbols indicating on the branch. So this is the code tree. Okay, so let us see one example so it will be more clear. So let us give input, that is 1, 1, 0. Initially, state here, one can see M, M1, M2, initially 0, 0, 0. So when you insert first bit, which is 1, and that will come here. So this will become 0, 0. Now when you insert next one, you will be finding this M1 and M2. So this one, that will shift here. This 0, that will shift here. And this 0, that will get discarded. And current bit is 1. So here will be 1. So when you enter next bit 0, so this is M1 and M2. So this one, that will shift here. this one that will shift here, and 0 that will get discarded, and current bit is 0. So 0 will be coming here. Okay. Now let us calculate output. Now see, as we have, okay, now let us calculate output. Okay, as we have, we know that what is our output. For this convolution encoder, which we know that is x1 and x2, and x1 equal to m1 plus m2, m plus m1 plus m2, which is modular 2 sum here, and x2 is m plus m2, and here also the modulo 2 sum. Now, so okay, now this is our output, x1 and x2. And now for all states, let us have calculate first of all what are the outputs. Okay, so initially if you have addition of m, m1 and m2, so here x1 that will be 1 plus 0 plus 0, so it will be 1, and x2 that is 1 plus 0, and it will be 1. Okay, so here output x1 and x2 is 1, 1. Okay, for second shift, here if you calculate x1, that is addition of 1, 1, 0. So that is 0. The reason is 2 ones are there, and in modulo 2 addition 1 plus 1 will be 0. And output x2, that is 1 plus 0, because x2 equal to m plus m2. So x2 is 1 for this case. Okay. For third shift, you will be finding it is 0, 1, 1. Okay. So it will be addition of 0 plus 1 plus 1 equal to 0. It means output of x1 will be 0 in modulo 2 addition, and x2 is m plus m2, so 0 plus 1 that is 1. So x1 is 0 and x2 is 1. Okay, so these are the output that is getting over here, and this is what we will be representing in terms of x1 and x2. So x1 and x2, that is 1, 1 here. In second shift, x1 and x2, that is 0, 1. And in third shift, here output is x1 and x2, that is 0, 1 also. Okay, so these are the output. Now, why I am doing this? Okay, the reason is code tree, because we are doing this for code tree. So I will explain how to create code tree based on states. So here M1 and M2, that is justifying states. So when M1 and M2 are 0, 0, state will be A. When M1 and M2 0, 1, state will be B. When M1 and M2 1, 0, state will be C. And when both are 1, then it will be state D. So here, in first case, M1 and M2, that is 0, 0. So 0, 0, that is in state A. So in first case, it will be in state A. And for second case, here M1 and M2, that is 1, 0. So for 1, 0, that is in state C. So it will be state C. And for last case or third case, for M1 and M2, 1 and 1, so it is there in state D. So it will be in D state. So after giving any input over here, we first need to see what is the state. So here I am not mentioning anything, but it will get shifted and you will be finding this 0 will come here and this 1 will come here. So based on that, one can say M1 and M2 is 0, 1. So for that, there is state B. Okay. In this diagram, where the first case where M1 and M2 is 1, 0, 0. Second case M1, M2 is 1, 1, 0. Okay, because here 1 is inserting. So this M and M1 will shift M1 and M2. And in third case, where 0 is inserting, so M will be 0 and M1 and M2 1, 0. Okay, so sorry, this M and M1 1 and 1 will shift M1 and M2. Okay, so 1, 1, 0. Here we are inserting 0. So this M which contains 1, it will be shifting to M1, and M1 contains 1 which will be shifting into M2. Okay, and the last, here I am not mentioning anything, as it means here we are not inserting any bits. So this 0 will come here. So here M is 0, so it will come to M1, and M1 is 1, it will come to M2. Okay. Now here x1 is 1, because x1 is the summation of all bits M plus M1 plus M2, which is modulo 2 operation. So x1 is 1 and x2 is the M plus M2, so it will be 1 plus 0, 1. So x1, x2 is 1, 1. For next case, x1, x2 will be 0, 1. And for next, x1, x2 will be 0, 1 also. And we know that when M1 and M2 is 0, 0, it means it is state A. When M1 and M2 is 1, 0, it means it's state C. When M1 and M2 both are 1, it indicates that it's state D. And here M1 and M2 is 0, 1, so it is in state B. Okay, so state A, state C, state D, and here state B. Okay, now let us have a code tree based on this. Okay, in this example where input is 1, 1, 0. Now see, as I have told you, initially it is in state A. So it means initially it is in 0, 0. So it is there in the state A. Okay, so let us make a horizontal line in state A. So at the end of this line, we have to mention A. The reason is they are in state A. And now here we give input 1. Okay. So when you give input 1, you will have to go by down step. Okay. So down step means input is 1 and up step means input is 0. So here input is 1. So you will have to go by down step. So here we have input that is 1. And let us make it to down step. And when you do this, output is 1, 1. Okay. So you have to mention output here. It is 1, 1. And it will be going to state C. So over here, you will have to mention state C. Now here, again input is 1. So you will have it, make it to down step because input is 1, and as you make it to down step, the output will be here 0, 1. So here it is 0, 1. Okay. And next step, state will be D. So you just mention here state D. So now next bit after state C, there will be 0 input. So here input is 0. So input is 0, make it with up step as input is 0. So I am making it with up step and output over here, that is 0, 1. So let us mention output 0, 1. And it will reach by step B. Over here, it will be in state B. So this is how we can make code tree. Okay. So all you need to do is first of all make a horizontal line, define a state, see what is the current input. If the current input is 1, make it a down step. If current input is 0, then make it to up step. And whatever output that is happening in that particular state, you will have to mention it on the line. So output, that is what we are mentioning on the line, and input is 1 or 0, that is we define it by down step or up step. And at the end of every step we will be defining in which state it is there. So at the end of the every step we will be defined in which state it is there. So over here it is state A, over here it is state C, it is state D, and over here it is state B. So here whatever output, that is we are representing, and this step, that is defining input. So this is how we can draw a code tree for convolution code, and hope that you have understood this session, and thank you so much for watching this video.